This video is to understand critical path analysis on a project schedule network diagram. The first thing which we should know is why should we do critical path analysis on a schedule network diagram. The first advantage is that we can find out the critical path and non-critical paths. The second is that we can find out total float and free float, also the project duration. We can optimize the schedule as well as we can mitigate the project risks. To get this understanding fully, we should also learn what is early start and early finish and late start and late finish in a project schedule network diagram. I have taken a very simple project schedule network diagram which has two activities. When the project starts, both the activities start in parallel, that is on the same day. First activity A is of 7 days duration and the second activity B is of 3 days duration. When both start together, the activity B will end on the third day, but the work on activity A will still be progressing until 7th day. And when both activities are done on the 7th day, then the project will end. So which activity determines the project end? The longer activity in this scenario. Okay. Now, what is early start and early finish? Can we delay activity B for a day? Let us delay it. Suppose I start activity B on the first day, it ends on the 4th day. Okay. Is it delaying the project end date? No, it is not. Even though this is ending on the 4th day, the project still ends on the 7th day. Can I further delay? Yes, we can delay. We can delay activity B further. So at the earliest, now we have started activity B and activity A at the earliest. So activity B is starting at the earliest on the first day morning. I have represented it with 0 and marked it earliest start. And because its duration is 3 days, it will end on the third day. So early finish of activity B is third day. Now let us take another scenario where, as I said, I can delay activity B. There is some flexibility in this path. Okay, so I can delay activity B. Now let us start activity B. See, I could have started on first day, second day, third day. Let us start on the 4th day. Will it delay the project end date? Project end date is 7th that we have already derived. So if I start on 4 days, its duration is 3 days. So it is going to end on 4 plus 3, 7 days. So on the 7th day, not on 7 days, but on the 7th day it is going to end. Is it delaying the project end date? No, the project end date is 7th. So there is no delay in the project end date. Now you have seen two scenarios. In the first scenario, activity B starts on the 0th day, or you can say first day morning, and ends on the third day. This is another scenario. As late as possible, if I want to start activity B, it will start on the 4th day and end on the 7th day. So this is called late start, late finish of activity B, or latest start and latest finish of activity B. We will learn in the future slides, coming slides, that this can be done only where there is a flexibility in the schedule, that is in the non-critical paths. Now come to the critical path analysis. So let us start with the forward pass. What forward pass says is that we have to traverse from left to right, and we identify, with the help of this forward pass, we identify early start and early finish of each of these activities on the network diagram. So let us start with a forward pass. We have a simple network diagram with activity A, B, C, and D. Project start is here. Project is starting here, and then activity A starts. Let us say that the activity A starts from 0 and its duration is 2 days. So it has to end on 0 plus 2, that is second day. Now, here we see that once activity A ends, activity B and C has to start because they have finished to start relationship. So when they have finished to start relationship, B can start only when A finishes and C can start only when A finishes. So A has finished. Now B and C both should start together. So on the second day, activity B will start, and on the second day, activity C will also start. Now let us go forward. It is starting, activity B is starting on the second day, and it has a duration of 3 days. So it has to end on 3 plus 2, 5, fifth day. Similarly, activity C will end on 2 plus 1, third day. Now let us see a scenario here where activity B is ending on 5th and activity C is ending on 3rd. So when will activity D start? Activity D has to start when both the activities are finished. And when both the activities will be finished, now activity C will be done on 3rd, but still activity B is running. Activity B will be done on 5th. So when can D start? D can only start on 5th, not on 3rd. Okay? Because the condition is both B and C should be done, then D will start. So we can easily see here, analyze here that activity D is starting on 5th. And when it starts on 5th, its duration is 2 days. So 5 plus 2, 7. It is ending on the 7th day. So with this traversal, we can easily find out a couple of things. One is that we got the project end date. You can see here, we got the project end date as 7th day. The second observation, because there is no activity beyond this, the project ends. The second observation is that we got early start and early finish of all these activities. Example, early start of activity B is second day, early finish is fifth day. Early start of activity C is second day, early finish is third day, and so on and so forth. So this is the conclusion here. Let us now do the backward pass. So when we do backward pass, we already have a project end date. Project end date can't change. So while doing the backward pass, we will carry forward the project end date here. Now please remember, on the top we have early start and early finish, these two. But at the bottom we have at the bottom here, we have late start and late finish. You can refer to this diagram. So this is the late finish. So late finish and early finish can't change here on the last node. So project is ending on 7th. Now we have to derive in the backward pass when it should start, when this activity should start. So 2 days duration ending on 7th. So 7 minus 2, this activity will definitely start on 5th. If you go forward, you can see starting on 5th and it has 2 days duration. It should end on 5 plus 2, 7th day. But we did this in the reverse direction as a backward pass. Now you can see if the activity D has to start as late as possible on 5th, then when should activity B and C be finishing? Okay, so these activities, unless they finish on 5th, activity D can't start on 5th. So this is bound to, so what we see here is that activity B should end on 5th. Also, activity C should end on 5th. Then only there is a possibility of activity D starting on 5th. Fine. So we have derived here the late finish date of activity B and activity C. Now we go further. 5 minus 3, 5 minus 1, 4, and 5 minus 3, 2. We have derived as we did in activity D, we are deriving here. The logic is that 5 is the late finish and this is finish date. So we have to derive the start date. So start date plus 3 will become the finish date, or finish date minus 3 will become the start date. So 5 minus 1, 4, 5 minus 3, 2 for the two activities. Another scenario is here. We have come up with start dates of 2nd and 4th for activities B and C respectively. Now what will be the finish date of A? So let us take an example where out of these two, 4th is the finish date of A. If A finishes on the fourth day, then activity B and C both must start on the fourth day. But you are seeing that activity B is starting on the second day. This implies activity A must end on the second day. So when activity A is ending on the second day, activity B can start on the second day. But why is activity C starting on the fourth day in place of 2 days? Because it is delayed. This is a late start. So this can be delayed. This activity's nature is such that this can be delayed. So though activity A is ending on the second, but activity C is delayed by 2 days, so it is starting on the fourth day. Once we derive the late finish date of activity A, 2 minus 2, 0 will be the start date. Now we are done with the backward pass. Now there is an important conclusion with this backward pass. First of all, let us see the formula for calculating float. The formula is LS minus ES. See, we can see in the diagram LS minus ES and LF minus EF both give the total float in this network diagram. So let us calculate 7 minus 7 is 0. 5 minus 5 is 0. So for this activity, the total float is 0. Okay. Similarly, for this activity 5 minus 5, 2 minus 2, 0. Both are 0. Here, the total float is not 0. 5 minus 3 is 2. And 4 minus 2 is 2. So for activity C, the total float is not 0. It is 2 days. What about the first activity? 2 minus 2 and 0 minus 0. So both are giving us 0. So please remember, the activities A, B and D have 0 float, and that can only be possible in a critical path. Now you have learned that in a critical path, the total float or free float, which I have not taught you so far, the total float is 0. But what about this activity C, where the total float is 2, 5 minus 3? This is not in the critical path. If an activity has non-zero float, then it cannot be on the critical path. So activity C is non-critical activity and it is not in the critical path. What about A, B and C? They are critical activities and they are on the critical path. Now I will tell you as a shortcut, how can we traverse quickly at the time of exam. So what we have to do is that start with 0, 0 plus 2 duration is 2. Next, move this 2 in a forward pass. Move this 2 here as well as any other node, parallel node. So 2 is coming here and 2 comes here. Now go node by node. 2 plus 3 is 5. 3 is the duration. 2 plus 3 is 5. 2 plus 1 is 3. Now we have a merge in the forward pass. When you have a merge in the forward pass, take the higher value and move it here. Okay. Now how to calculate the end? 5 plus 2, 7. The last node gives you the project end date. Now you carry forward 7 here. Okay. That is just like a rule. You do it for now because I have explained you enough. So make it here, and to derive the start date, 7 minus 2, latest start, 7 minus 2, 5. Now, once in the backward pass, you are getting this kind of thing where there are 2 branches, you carry forward 5 in both the branches here. So you have got now 5 and 5. How to calculate the start date here? 5 minus 3, 2, 5 minus 1, 4. Now there is a, merge. 2 here and 4 here, you are merging. In a backward pass, we have to carry forward the smallest value. So out of 2 and 4, we carry forward 2, and 2 minus 2 is 0. So this quickly I tell you, because in the exam we don't have so much of time to analyze. Okay, so we can do like this and then apply the formula and get the total float. Know the critical path, no non-critical path. If you like this tutorial, please subscribe, like, and click the bell icon. I have dedicated this channel for the people who are writing PMP exam. Also, I have a website easy-pmp.com where you can get all the other information on my training programs on PMP exam preparation. Thank you very much.